Bootstrapping is a technique that you need when you discover that your values are not normally distributed that you found in the sample, or when you know already that your population is not normally distributed for that specific characteristic. So in this case we found these values, and let's assume they come from a population that is not normally distributed. So how would we calculate the mean, standard deviation and margin? Not the normal way, for that assumes that it's normally distributed. So we need a technique called bootstrapping. We are going to find one random number from here, and we do that with the function index in the range A1 through A30, or whatever that range is, and from the collection of rows take one of them, multiply it with a random number between 0 and 1, so we have to add plus 1, and we found the first time 5 in here. It's this one. And then 46, etc. And we do that 30 times and we calculate the mean. Then we repeat this 15 times, let's say, because each time is a random result. So the more we repeat that, the closer we will come to the correct result. So we calculate here the mean of the means, which is the average of all these means, the standard deviation of those means, then the standard error. The standard error is the standard deviation divided by the square root of the number of cases. I use the count function to calculate that, -1. Then we calculate what is the borderline case, the t-value, with a 95% confidence. That means in a two-tailed test, t inverse two-tailed, we want a 5%, which is 2 times 2.5 on both sides of the curve. Then we can calculate the margin, that is the standard error times the t-value, and that margin is going to be used to calculate the lower bound, which is the mean of the means minus the margin, and the upper bound, the mean plus the margin. So again, if we repeat this all the time, in this case by pressing F9, we run that thing, and of course results vary because there is randomness involved. But we can get closer and closer to the more reliable result by running this 100 times, for instance. You probably don't want to put 100 columns here. So we are going to do that in VBA. And I did that already with Ctrl-Shift-B. And it runs that 100 times or 1000 times, whatever you want to do. And you will see that results vary. Here we have 4094, there we had 42. And the standard error, standard deviation are a little different. And of course the lower bound and the upper bound are different. And when we do it again, we will find other results, because it's still only 100 times done. So how did we get that VBA code? Alt F11 takes us here. In a new module, I put a subroutine which I call Bootstrap. I declared some variables. The two important ones are these. They are array variables. That means because of the open and close parentheses, they can hold multiple values. And we are going to calculate those values, and then we are going to calculate means and standard deviations, etc. So we have to find how many cases do we have. I did that on this line. In range A1, the current region, that is up to the next empty column and next empty row. Count all the rows, that's the number of cases we have, and then we set O range to a range that starts in cells 1, 1, which is A1, up to cells R1, which is in this case 30, 1. So that is A30. Then we redim the array means so it runs from 1 to 100, otherwise it will start at 0. For J1 to 100, that means we are going to run this time 100 times or 1000 times, whatever you want. Then we redim the array values from 1 to 30 in this case. So for I equals 1 to 30, we are going to store in the first element I, which is 1 the first time, and finally 30, the index function that uses O range and it does basically the same as we did here. The range, range is in this case A1 through A30, the number of rows times the rand function plus 1. Then we calculate from those 30 cases the average, and we stored it in array of the means, which is the first time 1 and eventually 100 or 1000, whatever you have chosen. And then we can do some calculations. What is the mean? We take the average of the array means. The standard deviation uses the function standard deviation for a sample of array means. And the standard error is the standard deviation divided by, like we found here, by the number of cases, the square root of the number of cases minus 1. So square root of r. Notice that in VBA square root is not SQRT but SQR. Then we calculate the margin, that is the standard error, times the t inverse function, two-tailed in this case. So we have a 95% confidence. And then we store that in the variable as message, which is just a string, based on 100 runs. And then a carriage return, space, ampersand, space. Expand that message with what we had already. The mean of the array means is p mean, but you probably want to format that to 2 decimals. You do something similar for the standard deviation, for the standard error. This is all very straightforward. The margin is the formatted margin to 2 decimals. Then the lower bound is p mean minus p margin, formatted to 2 decimals, and finally the upper bound. And then don't forget to finally display that string of information in a message box. And that's what we did here. If you assign a shortcut, Ctrl-Shift-B, then you will run this 100 times or as many times as you want, and it goes very quickly. So that is probably much better than plotting here a series of columns. That is more time consuming, not only for you to create it but also to run it.